Good morning. Today I'm going to be going over the financial modeling notes and a little bit of the homework. So to get started on the do first, go ahead and pause if you haven't read this already, because I'm just going to briefly go over the answer. So you can pause now. The answer to the do first, the first problem would be stratified because rooms on each floor are selected. So whenever we have our dorm, it's already grouped by floor, so we have it in the groups, and now someone from each floor is being selected. Not everyone from each floor, just some people. So that would make it a stratified sample. And these numbers are already in order on number 2. I'm not going to go over those. So the financial literacy review, modeling, I guess, begins with a review of the compound interest formula. And that formula is A equals P 1 plus R divided by N to the power of NT. So P is your principal, that's your initial amount that you invest. R is your annual interest rate. N, I'm going to write this one down because it's important. N is the number of compounding periods in 1 year. Number of compounding periods in 1 year. So then T is also important. It's the total years. Total years of investment. The important part here is that it's in terms of years. Let's go the other way. So for the first problem, reviewing compound interest, we have a principal of 100, so that's our P. Our rate is going to be 0.12. It's compounded monthly, so the total number of compounding periods in 1 year would be 12. And we want to know the balance at the end of 3 different time periods. So after 1 month, your T, because this is in months, we need to convert it to years, so our T is going to be 1 over 12. We plug everything in. A equals P 1 plus 0.12 divided by 12 to the power of 12 times 1 over 12. And I believe your answer is about $101. At the end of 2 months, your time would change to 2 over 12. And at the end of 1 year, your time is simply going to be 1. I will plug in the formula. A equals, oops, my P is 100. I meant to write 100 there. 100 times 1 plus 0.12 divided by 12 to the power of 12 times 2 over 12. And I need a pause. Well, I can plug it in my calculator. Oops. I used a 0 instead of a 1. There. 102.01. That's right. And then for the 1 year, it would be A equals 100. 1 plus 0.12 divided by 12 to the power of 12 times 1. Keep plugging things in wrong. 12. So this would be 112.68. Okay. In the back of the do first, there are 3 practice problems. I'm just going to, I encourage you to pause and try these, and then I'm just going to go over the final answer in a moment. So go ahead and pause, work them for yourself, and then unpause whenever you're ready to see the answers. So that's my principal. My time is 1. So amount is 100. 1 plus 0.11 divided by, for monthly, it's going to be 12. And then the exponent is 12 times 1, which is just 12. The A is 100 times 1 plus 0.03. Don't forget to move it 2 spots. Weekly would be 52, and then the exponent is 52. A equals 100. 1 plus 0.01. If it's daily, your number of compounding periods is 365, and it's 365 times 1. And whenever you work these out, this would be the least, this is the second least, and this would be the greatest. So the order would be, from least to greatest, it would be C, B, A. And you should convince yourself of that. Okay. Now to get into the, really the meaty part of the lesson, we learn about something called the time value of money saver, or the TVM. And the key difference between these scenarios that utilize this tool and the scenarios that involve the compound interest formula, and I'm going to write it down because it's so important. Going back to the compound interest formula, this is if you have a one-time deposit. So you put one lump sum into the bank and then you let it sit there and earn interest. Typically, that may or may not be the case. I actually have money deducted from my paycheck twice a month, and it goes directly into my savings account. So it's getting regular deposits on a regular basis. So in order to use the time value of money saver, these are all the variables we have to identify, and this is a table I'm going to continue to use as a reference. But to illustrate this example, I'm just going to dive right into the first problem of Derek's saving plan, but I tore out my table so that I can use it as a reference also. Okay, so Derek just got his first job after graduating from college. He plans to save $100 per month, deposited directly into his savings account on every payday the last day of the month. The account earns an interest rate of 3.6% compounded monthly, and his grandmother gave him $1,000 to start the account. You could do all of the TVM problems using a recursive sequence. So I'll go ahead and give you that sequence, but my focus today is going to be on the TVM solver, not the sequence answers. So for the sequence, our initial amount would be $1,000, and the amount each month would depend on the amount on the prior month. One thing that we're doing, we know that we're adding $100 to that amount, so I'm going to do plus 100. But on the first day of the month, let's say he is this amount. In January, for instance, as we roll over into February, that amount is going to be adding interest. And the factor for the interest is 1 plus 0.036 divided by 12. Essentially, this is going to be a growth factor. That's why it's greater than 1. And the amount that it's growing by is 1/12 of the 3.6% interest. So it's 1/12 because we're only getting 1/12 of that piece a month, so that by the time you reach December and our account has been there for a full cycle, the full year, it's reached a total of 3.6%. That's their annual percentage rate. So we could, if you like sequences, you could use this sequence to find how much he has at the end of 5 years. I'm going to show you how to do it using a TVM solver. Okay, so the way that you get to the TVM solver is from Calculate screen. You're going to go to Finance, and then Finance Solver. So click Menu, and then go to Finance, and then Finance Solver. and this whole box pops up. So your box, it automatically loads the last numbers that were used, so we're going to want to overwrite those because we have a new problem. N stands for, that's maybe the trickiest thing to find. Let me scoot it back over here. Again, this is the table you have in your notes. This is the total number of compounding periods of the investment or the loan. So if Derek, it's compounded monthly, and he has this going for 5 years. If we see right here, there's 5 years, monthly 5 years. So the total number of compounding periods is going to be 12 times 5. So there's 60 times over those 5 years where the bank is adding interest to his account. There's also a little helper box down here that tells you what each piece is. But I would encourage to use this as well as the table in your notes, because the table in your notes has a more detailed description. So I is a percentage rate, but it needs to be in a percent, not a decimal. 3.6. Present value. I'm going to make a note of this in my table. So this is your initial deposit or initial loan, because we can use this for loans too. Present value, if we're depositing money, it's going to be negative. He's depositing $1,000, his grandmother anyways. And the way that you can kind of remember that, if it's not in your pocket immediately, then it's going to be negative. You don't have access to that money. So it's going away from his, from his piggy bank, and it's going into the bank. Yes, it's still his money. No, he's not giving it away, but it's going in the reverse direction. Payment. That is your monthly payment. And for him, it's negative $100. So again, it's going out of his his wallet and going into the bank. Future value. That is exactly what we're looking for. The problem says how much will he have? So we're going to leave this entire box blank. Payments per year. This is the amount of times that he makes the monthly, that payment. So however many times a year this $100 takes place. So it's 12. Compounding periods per year, that's the amount of times that the, how often it's compounded per year. And for now, and by default, we're going to use payment is at the end of the period. So this just means the interest is compounded at the end of the month, not the beginning of the month. And sometimes it's not very clear, to be perfectly honest with you. But I think typically this would be the case in the real world. So once you have your numbers, you need to bring your cursor back to the future value box, and you just push enter, and it solves the problem for you. So for part B, the amount that he would have would be 7760.05. So that's what his money grew to, with those monthly deposits and with that initial deposit. On the next page, I'm going to work through a couple of examples, just kind of giving you what the variables would be, and your answers are already in the notes. The tricky part is figuring out what these numbers are. So go ahead and, well, we can talk. Julia's parents, they're saving for a college education. They put $5,000 in an account on the day she was born. That is my present value, so minus 5,000. I'm just going to fill it in as I read the problem. What payment P, so payment is going to be our question mark, do they make at the end of each month to accumulate $40,000? That's my future value. Over 18 years, this is going to have to do something with N, but I don't know how frequently it's compounded yet. It earns 4.8% interest, 4.8. It's compounded monthly. So now I can put together the pieces for my N. It's going to be 12 times 18, which I think is 216? Yep. 216. Payments per year would be 12, and compounding periods per year would be 12. And then again, I will select end. And yes, this should be, your calculator gives you a negative number, but I just want us to think about this logically. So if someone asks you, how much do you deposit in your bank each month, you're not going to say, I deposit negative $50. No, you deposit $50, okay? So that would be how you back out and get the 8230. Number 14. Let me zoom out. Okay. At the end of each month, Tara has $100 deducted from her paycheck. That is my monthly payment. And put into a savings account earning 4.8% monthly interest, so 4.8. And it's compounded monthly, so the N is going to be 12 times the number of years. So she deposits this for 10 years. There we go. How much will be in the account at the end of 10 years? So we're looking for future value. My payments per month is 12 because she's doing 12 payments, their monthly payments. Compounding periods per month is 12. The TVM Solver doesn't allow you to solve for more than one thing at a time. So I have to fill in, I already know I'm looking for future value. That means I need to have a present value. In the prior problems, the present value was the initial deposit. But we have no initial deposit here, so our present value is going to be 0. Okay, it's going to be 0. You do all that, you should get your future value is 15,363.20. I am going to leave number 18 for you guys. I don't want to work out every single problem. So the answer is here. Your goal is to figure out the numbers you need to manipulate to put in for problem number 18. Okay.